A ball is tossed straight up from the surface of a small spherical asteroid with no atmosphere. The ball rises to a height equal to the asteroid's radius and then falls straight down toward the surface of the asteroid. What forces, if any, act on the ball while it's on the way up? Well, it changes direction, so we know it had to accelerate, so there must have been some force. So D is out. This is similar to a free fall problem, so we know there's only one force acting on it because it says there's no atmosphere, there's no air resistance. So I'm left with choices A or B. Only a decreasing gravitational force in a downwards direction or a constant gravitational force in a downwards direction. The instinct on this one is to say that it's B, a constant gravitational force downward, because that's what we learned about in free fall in kinematics. But the Earth's pretty big. Its radius is roughly 6 times 10 to the 6th meters. So, and I can throw a ball, I don't know, say I can throw it from the pitcher's mound to home plate. That's only 20 meters. It's pretty insignificant. So if I'm looking at just the denominator of the gravitational force equation, here, all right, at the surface, it's 6 with 6 zeros squared. If I add that extra 20 meters, it's ever so slightly different, but not enough to make it an effect on the motion of the ball that we can measure. Okay. However, on the asteroid, clearly not drawn to scale, it has some radius, okay, and so the denominator on the force equation is going to be r squared. After that ball is thrown, its distance from the center of mass is 2r squared, which means I'm now 1/4 the original force. That is a significant distance, so we can say that clearly there is a decreasing gravitational force on the way up.